Hi, we're going to see the concurrency points of a triangle, and you're going to see something really cool and really amazing about the concurrency points. So keep in touch until the end of the video because we're going to see something amazing about the concurrency points. The first concurrency point we're going to work off is the circumcenter, that is finding using the perpendicular bisectors of a triangle. So perpendicular bisector number 1. Now we're going to take the perpendicular bisector number 2 and the perpendicular bisector number 3. Now, as you know, the perpendicular bisectors, now we're going to get the circumcenter. This is the point of concurrency of these 3 lines here. So now we have the perpendicular bisector. This is the concurrency point, this is the circumcenter. And why is calling the circumcenter? Because if you do a circle whose center is the circumcenter and passes by one of the vertex, is going to fit with all the vertices. It's the circumscribed circle. Now we're going to find the incenter. The incenter is finding using the angle bisectors. So the angle bisectors, we're going to find the angle bisectors of each triangle. You know how to do it using compass, so I'm just going to do it here using this program. The perpendicular bisectors, and with the perpendicular bisectors we'll have the next concurrency point, that is the incenter. Okay, this is the incenter. And what is the incenter? The incenter, it's a point that in which you have a circumference that it's inscribed in the triangle. It's inscribed in the triangle. Okay, as you could see, this is the incenter. You can do a circle inscribed in the triangle. This is the cool part of the incenter. Now we're going to find the altitudes. The altitudes are just perpendicular segments to one side that reach the vertex. In this case, this is the first altitude. Look at this, perpendicular to the side of the triangle and reach the vertex. So first altitude. Now we're going to find the next altitude. Look at here. And finally the last altitude. And here we have found the incenter. The incenter. So let me show you the incenter. The orthocenter, excuse me. The orthocenter is here. So we're going to set a point, the point of concurrency of the lines, and this is the orthocenter. So far we have orthocenter, incenter, and circumcenter. Okay, and finally we're going to find the centroid. The centroid is given by the line that is starting from the midpoint of the segment to the vertex. So we're going to use the midpoint. So I'm going to take all the midpoints here. Midpoints. Obviously the midpoint is the point in which the perpendicular bisector crosses the line. Yeah. Now we're going to do lines that are moving from the midpoint to the vertex. Midpoint to the vertex. So midpoint to the vertex. And finally midpoint to the vertex. And this is the centroid. So the centroid. the centroid. So what is the centroid? Here is the centroid. Okay, so we have the 4 points: circumcenter, centroid, centroid, incenter, and here is the orthocenter. Here is the orthocenter. Now, depending on the triangle, these points are going to change. Depending on the triangle, these points are going to change. So, what happens if I move the sides of the triangle? What's going to happen to all points? Look at. If I change one side of the triangle, all the points could change. Look at, for example, take a look at the circumcenter. Depending on the triangle, the circumcenter could be inside the triangle or outside the triangle. Okay? And depending the triangle, the orthocenter could be inside or outside the triangle. Depending. Look at, I put the orthocenter, look at the orthocenter here, could be inside the triangle or outside the triangle. Okay, and now I'm going to fit all the points into the same line. We have all the points in the same line. What's gonna happen if I put all the circumcenter, incenter, and orthocenter in the same line? We're going to have an isosceles triangle. The isosceles triangle should have all the concurrency points in the same line. And this is something that I think that is really cool. Look at, I can change anything: circumcenter, incenter, centroid, orthocenter. But if I'm trying to have an isosceles triangle, they are going to give into the same line. And that's pretty cool for me, because it's telling you that a isosceles triangle helps you to have something interesting about the midpoints, the concurrency points in a triangle. So thanks for watching. I'm pretty happy to be here, pretty happy to help you. Like if you enjoyed the video, share if you think that it's important for people who study geometry, the concurrency points, and make some comments and tell me something about other videos or about this video. Thanks for watching and see you next. Goodbye.